Hi, everybody. My name is Emily Gorcenski, and I want to talk to you today about building better SLOs for data-intensive systems. Now, when I talk about data-intensive systems, what I usually mean is things like BI systems, machine learning systems, or any type of application where a large amount of data is necessary for the basic function of the system or the basic operation of the system. So the reason that I want to talk about SLOs for data is because, frankly, data is in a pretty rough place. Data AI analytics, we see a lot of problems in this space. There's a lot of challenges with data. We hear things from industry like platform teams are creating a bottleneck, or we spend a lot of time cleaning data, or it's hard to find the right data. And I think that it's pretty common to talk to data engineers who are pretty fed up with always firefighting, and data scientists who are always fed up with poor data quality and poor data discoverability, long times to production. And this is really critical because finding data engineers is hard. Retaining data engineers should be a priority for any business. And the biggest problems that we hear have to do with reliability of data. So how can we use reliability engineering theory to design better data systems? What do we need to create in order to do better tracking, do better engineering, and keep these systems running with higher reliability? In order to understand this, we have to understand the difference between data systems and what I like to call deterministic systems, meaning systems where the operation is driven through business requirements or through specifications rather than through the inherently uncertain and probabilistic nature of data. A lot of data teams will talk about SLAs, they'll talk about the need to create insights, the need to have data available by certain times. But these SLAs really don't use or leverage the best of what SLO theory has to offer. And I'm sure that there are other talks here that will go into what the difference between an SLO and an SLA is, and why we should be looking at SLOs to drive engineering improvements and drive team improvements. So I won't go into that, but I will talk a little bit about why data is different. When we look at typical distributed systems like microservices, what we see is a low value per transaction that we make up for with high volume of transactions. So each individual search is not going to make you a bunch of money, but if you have lots of searches, or if you have lots of successful login processing attempts or whatever, that will eventually add some sort of value to your software. Also, in these operational systems, we see that the user holds the data. I have my login credentials. I know what I need to do, and the system performs a function. The service needs to take that data, crunch on it in some way, and emit a response. In analytical systems, this is a little bit different. We don't see, tens of thousands or hundreds of thousands of users per day working in these types of systems. We see maybe hundreds, sometimes in the low thousands of analysts, depending on the size of the business, working in things like BI systems, machine learning systems. But the value that is created by a single interaction with these applications is much, much higher. When I create my daily sales report, it tells me what I need to reorder to keep my supplies heavy, or where I should market my products. There's a lot of money riding on the decisions that I can make with that data. Also, in these types of systems, we have a sort of a different situation. The system is holding the data and the user is performing a function. My data warehouse has the data. I'm the one who needs to pull it, analyze it, interpret it, drill down, do some forecasting, whatever. Right? And so we have a different type of situation that needs to, that merits different types of SLOs. Good SLOs, as you know, are very hard to define. And what we want to understand is that the conventional SLOs, if you read the SRE books or Alex's great book, these microservice-oriented SLOs don't really work for data because latency doesn't really matter for an analytics query. because you can't specify ahead of time what the query will be. It could be something super simple, or it could be something with a lot of joins that will take 10 minutes to crunch because the volume of data is so large. So we need to use a principles-based way of creating the SLOs. The first thing, of course, is that SLOs should be connected to the user value. They should allow us to have some wiggle room for experimentation, and they should inform engineering improvements. But most importantly, these SLOs should be monitorable and visible. And oftentimes when I see data and analytics teams trying to create SLAs, they're doing this in a way that doesn't really lend itself to automation, monitoring, or visibility. Things like the number of bugs that need to be cleared or the time it takes to clear a bug. There's not a lot of great tracking behind that. And so you can't really use them as anything else other than, a sort of a slap on the wrist if you think a team is underperforming. So we want to get away from that mindset. And I'm going to create an example here that should hopefully make you think of data systems as a little bit different than just infrastructure. So imagine that we have a sales report, a daily sales report, and we have analysts that need to work on this every day. And many people need this for many different purposes: inventory replenishment, sales forecasting, marketing spend, whatever. And this report usually takes several hours, say 3 or 4 hours to run. And so we run it overnight. And typically these types of jobs, something fails, usually pretty frequently, like the Spark cluster falls over, or there's missing data or something like that, right? These are the typical problems that we see in the data space. And so if we wanted to take an SLO-driven approach to doing this, if we start with something like uptime, we might come up with like a microservice SLO, like the data warehouse must have 0.9% uptime. This isn't a very good SLO though, because I can have my data warehouse operational and it can return a query successfully. But if the data is old, or if the table is empty, or the data is wrong, it's not actually serving its purpose. It's not doing its job. You can't separate the system availability from the correctness of the data, right? So it's sort of an orthogonal problem. We don't actually care about the data warehouse being up. We care about the data being correct. The data warehouse is merely a vessel through which we communicate or make this data available to someone. And we're paying for a lot of availability during times that our analysts aren't working. Let's say they work from 7 in the morning till 7 at night. Why should I care about my availability at 11 o'clock on a Saturday night? I don't. So if we can try to do a little bit better and say something like an SLO, like the job must be completed by 7 a.m. every day. The problem with this is that this is very binary. There's no wiggle room. It doesn't tell us anything. It doesn't tell us what's wrong or how to fix it. It just tells us, bad job. Your data processing job hasn't completed in time. You've done something wrong. We want our SLOs to be decomposable, especially around data. We want them to give meaningful distributions. You can't really create a distribution from a bunch of binary yes, no's. I mean, sure you can, but it's not going to tell you anything useful. So maybe you try to actually give yourself some wiggle room and you say, oh, let's call it 99% of the time it should be done by 7 in the morning. And this is better, but it still doesn't give us anything decomposable where we can try to understand what we're doing. There's no window. There's no 99% of what? Over a year, over a week? What does this mean? This is a meaningless metric for a binary outcome. So let's actually think of it differently. Instead of measuring whether the job is completed or failed, let's measure the number of minutes beyond 7 in the morning every single day that the job has not successfully completed. And we can bake a trigger into our data pipeline that checks that the data is correct, that checks that the job is run, and sends a signal when that is complete. So we can track this, automate it, and monitor it. Then let's give ourselves a little bit of an error budget. Now, I know error budgets are not the best tool to use, but let's give ourselves something because we're starting from nothing in the data space. And let's say that, 270 minutes over any 30 working day window, we're allowed to not have that job be completed. This is great because if, say, Mondays our job takes a little bit of extra time because it has to process the weekend sales. If it's 5 minutes late, who cares? It's not even going to enter into our error budget. We don't even really look at it. This gives us a lot of wiggle room to figure out where we can improve. What's really great about this also is we can look at our job, figure out how to decompose it, figure out what parts of the job are taking a long time to run, and design better data pipelines that allow us to create automated restarts, to do self-healing data pipelines, to allow us to start the data pipeline from an intermediate step, and allows us to improve the efficiency of those pipelines, which allows us to shrink the time of the job. More importantly, this is directly connected to user value. We are valuing the minutes, the actual time that our analysts have to work. We're not just saying, sorry, no data today. We're actually valuing that they have to do something with this data over the course of their day, every single day. And every minute that it's not available means that they're not able to do their job properly. It means that we're actually respecting the work that they're doing, and we're able to design a system that we can improve over time and make it better. And so what would this be in terms of an SLO? Well, if you do the math, what this would be is we can redefine our uptime. 270 minutes over a 30-day working window is about 98.75. We can round it up to 99% uptime. So as with any good SLO, it depends on how you measure it, depends on how you monitor it, depends on how you define it. And so we can define better SLOs for data. And what's really important, and I'll finish up here, is that these can be baked directly into our data pipelines. We don't have to do fancy monitoring, doing any sort of avant-garde log processing on our Spark clusters or something. We can bake this directly into our data pipelines and have a really great, easy to implement, automated, code-based SLO monitoring system. You can do this for data accuracy, data completeness, all sorts of other things. We just need to rethink the definition of our system to really be data focused. So thank you very much. I'll be around to answer any questions. Thanks for watching. I hope that this was helpful, and I'm happy to take your feedback. Take care.